Indeed. 3, comma 0, negative 1, comma 0, 4. Y-intercept. How do we get the y-intercept?
0 plugging 0.
Yes. Yes. We find f of 0 to be negative 3. So 0, negative 3. 5. We want to find the vertex, which in this case is a minimum. And remember, negative b over 2a. So how do I remember this forever? Well, from the quadratic formula. So if you remember, the quadratic formula was negative b, or is negative b plus or minus the square root of b squared minus 4ac over 2a. This is the x-coordinate of the vertex. Very easy to remember. Anything except the plus or minus and the square root. That's the x-coordinate of the minimum or the maximum of any parabola. Negative b over 2a. So then negative b over 2a, can anyone tell us what to write into that negative b over 2a? If you want, we can identify them here. So we have them in front of us.
It's 1.
Yes, indeed.
2.
Yes.
C is 3.
Negative 3.
Negative 3.
Yes. Good. Although c is not necessary in this case, so I have the negative from the formula. B, which is negative 2. 2 times a, which is 2. There are only 2 negatives. So what is the answer here? What do we get here?
1.
Good. So the vertex, or the minimum in this case, is 1 comma, but we have to find f of 1. Can anyone plug in 1? What do we get? Because I need the y coordinate of the vertex. I have the x, I need to find the y. How much? How much is f of 1?
Negative 5.
So we have 1 minus 2 minus 3, right? Negative 5 plus 1.
Negative 4.
Good. Good. So now the last few steps. Number 6, axis of symmetry. Here's the vertex. Can anyone give us the axis of symmetry? In this case, the minimum value is what is the axis of symmetry?
1.
X equals 1, indeed. And the minimum value is?
Negative 4.
Negative 4. And number 8 in a minute, range. I already know how the graph looks like. With a minimum at negative 4, what could be the range? Now we already pictured the graph. It has a minimum, and the minimum value is negative 4. What could be the range? Before I even graph it, I can determine the range now. What do you think? If it's not clear, we'll graph it first.
Negative 4 to infinity.
That's it. Indeed, very good. Excellent. Good. So then, I always start with the vertex. 1, negative 4. I continue with the axis of symmetry, which is x equals 1. I continue with the y-intercept. I continue with the x-intercepts. And I'm done. Not too acute at the vertex. And try to keep it in shape. And this is f of x equals x squared minus 2x minus 3. And this is -4. So obviously the range is from -4 to infinity as expected. Now, what is the difference between what we just looked at and something like this? F of x equals x minus 4 squared minus 1. No difference. The only thing is that this function has completed, has the square completed already. I'm not going to expand it. No. What is the beauty of this? If you remember, what is the base function here? From transformations. What is the base function used here? From transformation, which base function was used to create this function? Was it the absolute value of x? Was it the square root of x? Was it x cubed? What was it? We are using what we learned before.
Is it linear?
So which base function, which simple function was used here?
Quadratic.
Yes, the x squared, right?
Oh,
What will be the first transformation? In order of operations, what is the first transformation on x squared to get this?
Move right 4.
Indeed. So right 4, excellent. And the last one, which is a transformation on this,
Is down 1.
indeed, -1, down 1. Can anyone picture the vertex of this parabola without even graphing it? Right 4, down 1.
4, -1.
This is it. So here's how we get the parabola with the vertex. Here, we worked hard. We had to determine -b/2a. We had to plug it in. Not here. If the square is already completed, here is how we see this. Because you told me this on your own. So you know where the vertex is. So the formula is f of x equals a, x minus b squared, and plus c. So the vertex will be b comma c. Exactly what you told me. This cannot be changed. So this is exactly what you see. But of course, x minus 4, the vertex is 4. So here's one other example before we continue. These are notes, right? So if I have, let's say, f of x equals -2, x plus 1 squared, and plus 2. Can anyone, with no calculations, identify the vertex?
-1, comma 2.
That's it. Here's one more. Let's say -4. For this one, can anyone identify the vertex?
-4, -4,
That's it. So if the parabola is given to us like this, in this format, with the square already completed, it is a little bit easier because it's very easy if you want. We still have to go through all those steps, but I don't have to calculate anything. I can determine the vertex in a blink. I don't need to find negative b over 2a. I don't need to go back and plug it in. No, it's already done. I'm looking at it. Okay, so let's start again. So this was, I'm going to start again because I want to put everything together. So we have f of x equals x minus 4 squared minus 1. In number 1, as you know, there is no discussion. Domain is all real numbers. In number 2, you already told me the vertex. It's 4, negative 1. That's done. In number 3, the x-intercepts. Now this may require a little bit more work this time, because I have to set y equal to 0, and here's what happens. I have x minus 4 squared minus 1 equals 0. Of course, I have to move 1, and then I have to apply one of the methods that we used before on test 1. Which method is that?
Square root.
Yes, we have to take the square root from both sides. The left-hand side is x minus 4, but if I forget something crucial on the right-hand side, I will not be able to get the correct solutions.
Plus, minus.
Plus or minus 1. We have to move 4. And then the options are the one with the plus and the one with the minus.
Negative 3 and
5 and 3.
5 and 3, indeed. So 4 plus 1, 4 minus 1. 5 and 3. So we have 5 comma 0 and 3 comma 0. Good. So in number 4, we have the y-intercept. Now that may be slightly more difficult because now I have to be careful. 0 minus 4 is negative 4. Negative 4 squared is always a positive number. 16 minus 1, 15. So 0 comma 15. 5, 6, and 7. They're just words, basically. Can anyone identify the axis of symmetry? In this case, I forgot to mention, right? The leading coefficient is here. This is the A. So it's a minimum. So I'm going to put it here. A equals 1, so it's a minimum. We already knew, we established that because of the transformations, but I should have written it on the side. So can anyone give us the axis of symmetry and then the minimum value?
Four.
Yes, indeed, x equals 4. And the minimum value is?
Negative 1.
Negative 1. Very good. And now, can anyone picture it's a minimum? It's a minimum, and the minimum value is negative 1. Can anyone give us the range without even graphing it? Because we already see the graph.
Negative 1, comma, to infinity.
Indeed. Perfect. We're ready to graph it. We start with the vertex. 1, 2, 3, 4, negative 1, right here. Axis of symmetry. X equals 4. Y-intercept. Y-intercept. Gee whiz. $15. Perfect. X-intercepts. X-intercepts. 5 and 3. Notice that they have to be symmetric, right? This cannot be at 10 and this one at 3, right? They have to be symmetric, 1 unit away from the axis of symmetry in this case. And now I'm trying to graph this, making it as smooth as possible. So this is the graph of f of x equals x minus 4 squared plus 1. Minus 1, sorry. Any questions on graphing parabolas? Any questions? Now, I want to make here a correction because we're not using B and C for this. We're using K and H. H and K, same thing. So H and K. The reason we're not using B and C is because we have f of x equals a x squared plus bx plus c, and they mean something else. And a is the leading coefficient in both. So we're using H and K as a general formula. Okay, any questions? If no questions, I would like to go to word problems now. Any questions? Okay, I'm going to share my screen. And let's take a look at 3.1. I don't want this, I want the e-text. And I want the page to be 363. The major application here is finding a max or a min in a situation in which a quadratic function is involved. So I'm looking for 363. Okay. So let's choose a problem here. When the shot whose path is shown by the red graph, where is the red graph? I guess on the previous page. So we have this, and we also have this. So they're talking about the red one. Okay. Good. Let's see what they want. Is released at an angle of 65 degrees. Its height is given by this. So this function is the one graphed here. This is the function. They already graphed the function for us. And I don't want to forget something. Here is how we graph. So this was our function, the first one that we looked at. We go to zoom and 6. Here's the graph. And this is what we graphed. Of course, the calculator does not present the axis of symmetry. Okay. Now, how do I determine the maximum? It was determined already, but how do I determine the maximum with the graphing calculator? You go to second and calculations. Second and calculations. And you want to determine the maximum, which is 4. Click on 4. The calculator is asking you, okay, you want me to find your maximum, but give me a bound. Give me a left and the right where you want me to look for that maximum. So I'm going to say -4. I know where the maximum is, but I want the calculator is asking me for some bounds. So I'm going to say between -4 and 0. So calculator will find the maximum between this point and this point. I don't want to guess. I know the maximum, but I don't want to guess, so I press enter again, and here it is. When you see something like this, you know this is the tolerance of the calculator, meaning almost everything has a minor error somewhere. So it's not -2.0000001. No, it's -2,9. And that's what we got before. So coming back to our book, they already graphed the function for us. Okay, so let's see. Then this is it. That's the g of x. Does it have a maximum? Yes, because the leading coefficient is negative. And x is the shot's horizontal distance in feet from its point of release. Yes. This is x. This is x. The horizontal distance. So, for example, at the maximum, the horizontal distance is this. When it already falls on the ground, the horizontal distance is this. So that's x in feet, they say. Use this model and answer parts A through C. What is the maximum height to the nearest tenth of a foot? Okay, so this is 58 on page 363. And I have g of x, I have to copy it, negative 0.04x squared plus 2.1x and plus 6.1. And they want us to find in part A the maximum. I know it has a maximum because the leading coefficient is negative. So how do I find the coordinates of the maximum? What do I have to determine? The square is not completed. I'm not going to complete the square. This is going to be a tremendous task. No, because I have another option of determining the vertex. So what do I have to calculate? What does the x of the vertex? What does it equal to? What does it equal to? What did we say? Why did we say it was equal to? How do I find it? Anyone, please? Please? Does anyone remember?
Said it is 0.
Negative b over negative b over
2a.
2.
indeed. So it's negative. Here's the b, 2.1. 2 times a is negative 0.08. So let's calculate that. So here it is. Get out of there. So we have 2.1. Of course, the answer has to be positive. 2.1 divided by 0.08. So 26.25 feet. That's the x. What does it mean again? Oops. What happened to my book? What happened to my book? Okay, so that's the x. The location of the maximum. As expected, look, right here, 26.25. Now I need to determine the maximum. How do I determine the maximum? So this is 26.25. How do I determine this value? Because this is the location. This is where it happens. But that's not the maximum value. This is the maximum value. How do I determine the maximum value? Please. What do we have to do to determine the maximum value, please? How did we determine this before?
Do you have to plug in 26, 2022
Yes,
equation?
absolutely. G of 26.25. Absolutely. Thank you so much. So please do this. Always look at the function, clear, and the function is negative 0.04x squared, and then plus 2.1x, and then plus 6.1, I see it, the function is entered correctly, yes. Second and table, and I plug in 26.25, and I get the maximum value to the nearest tenth. Okay, fine. 33.7. 33.7 is the maximum in feet. 33.7 feet. So, what is the maximum height? We determine it, 33.7. What is the shot's maximum horizontal distance? Of course, this makes no sense. I have to find the horizontal distance first. I cannot find the maximum value, my maximum height first. I already found this. It's 26.25. From what height was the shot released? What do I need to determine to find out this height? So obviously this is the x-intercept, and this is the y-intercept. So this is when x is 0, and this is when y is 0. So this is basically a plus b. I cannot separate these. And in C, I have to find g of 0. 6.1 feet. So that's where it was shot from. Yes, I'm going to be quiet for the next 10 minutes, I promise.